All right, so questions 2 through 4. The first two are pretty straightforward. The last one can be a little bit more challenging. So here we're given this information about crows and how much lead they have ingested. So we looked at a sample of 23 crows and we measured and recorded their lead levels. So it is clear that our variable here is lead levels in parts per million, which is quantitative. So already my mind is going, we're doing something with means because we have quantitative data. Then we keep reading. The mean lead level of the 23 crows in the sample was 4.9 parts per million. That's very nice. They gave us X bar. They're not going to make me enter that terrible stem plot into my calculator, with a standard deviation of 1.12. So again, thank you so much. I'm happy to not have to enter stuff in my calculator. And then it says, let's construct a 95% confidence interval. So if I'm going to my formula sheet, I'm going, all right, we wanted to do something for means. We wanted a confidence interval. There's my formula. So I'm just going to pop that guy down on the page. Boop. X bar plus or minus T star S divided by the square root of N. We just translated that X and that S. And we have our N. They must have told us, oh, yep, 23 crows. The only thing we need is to go figure out our T star, which we know is based entirely on this confidence level. So you have a 95% confidence level. And for the t-table, we need a degree of freedom, which is going to be n-1 or 22. So that's the last piece. Go into my t-table. We need 22. And we need 95% as our confidence level. So 2.074. I've already lost my pit. There it is. 2.074. And once we calculate that, we'll get out our confidence interval. So we should end up getting the following confidence interval. And remember, if you have the calculator, the graphing calculator, you're just doing a t-interval. Make sure that you give me the calculator shortcut you used. Interpretation, well, we need to say we are 95% confident that and remember, you can usually steal this from the actual question stem. That makes sure that we get the right variable or parameter. So we're talking about means, not proportions, right? What the context is, this is lead levels for crows in the region. And then we'll say is between 4.4156 and 5.3844 parts per million. Got our units on there because we're talking about means. Boom. Now 4 is where a lot of students got tripped up in my last test. And again, you can see double stars, extra credit. This time we are asked to construct a confidence interval for the proportion, which means I need a categorical variable. And it says classified as unhealthy. Well, that's a nice binary variable, unhealthy, healthy. It required us to go back up and read that greater than 6 is unhealthy. So all of these crows right here would be considered unhealthy, which means that 4 unhealthy crows. And we know how many total. There was 23 crows. So if we wanted to do this second interval, we're sitting there going, okay, I have a p hat. That's 4 out of the 23 crows being unhealthy, which is 0.1739. And I know how to make this interval. It's p hat plus or minus. I'm just going to the formula sheet here. P hat, q hat, all over n. So that was how you calculated this interval. A lot of students wrote down just the formula and then couldn't figure out where they were supposed to get the p hat. I gave them some partial credit. A lot of students decided they would use 0.5 because we didn't have p hat. That's only true for sample size calculations. But all in all, this is what we should have done, is figured out how many would have been classified unhealthy. I'm trying to do math and talk at the same time, which is going to be a disaster. So anyways, that's where the answer came from on the answer key for this problem. Number 5, again, we're sitting here, we're talking about sales prices of homes. So before we even get started, we realize we're talking about a quantitative variable, and therefore we've got to be talking about something with means. And then we keep going and we're given a mean and a standard deviation. This is actually talking about all homes though. It's not even from a sample. So technically they've given me a mu and a sigma, strangely enough. And they told us it was right skewed, which is also strange. But this all makes sense when you get to the final sentence of this. It says, which of the following describes the sampling distribution of the sample mean? Now remember, when we talked about sample means, we said x bar either follows a normal if our distribution is originally normal, which we know is not true here, or x bar follows an approximate normal, which could be true for us if n is greater than or equal to 30, and we do have a sample of 100. So here's what our sample mean should follow, an approximate normal. So D and E are immediately out because D and E are talking about the original distribution and not the distribution of sample means. And through the central limit theorem, as we saw in the StatCrunch simulations, our means will always end up normally distributed, approximately normally distributed. Last piece, I forgot to save that last piece. This is going to be a double video. Gross. Anyways, last piece here is then to go to our formula sheet if we don't have this on our note card. And we need the mean and standard deviation for a sample mean. So the sample mean is going to be centered at the real mean, but the standard deviation is going to come in as our sample size increases. So if we grab both of those, we recognize, okay, the mean is always going to be 206. That doesn't help us. But the standard deviation of a sample mean should be the original standard deviation divided by the square root of n. So 37881 divided by the square root of 100 is just going to end up 3788.1, which is A. So that was all 5 was about. A lot of students got distracted by the strongly right skewed and just didn't pay attention to that last sentence saying, we want to talk about the distribution of a sample mean.